several homework problems from the number sense, which I think is week 2. And I'm going to be writing down some rules for like the addition and subtraction of signed numbers, the multiplication and division of signed numbers, your order of operations, your PEMDAS, as hopefully you've heard before at least 5,000 times in your life, LOL. We'll do some problems that they go with, and yeah, that'll be it. I am going to have to end class a little early today. I have something important going on. If I was able to pre-record the video, it wouldn't have been an issue, but I will have to end just a little early, and it might be like 1:30, 1:20. It just depends. So I'm sorry about that, but we'll still get enough information. So let's go ahead and get into this. And the only way I could get this to work was by using what used to be Internet Explorer. Chrome was just giving me a headache. So we've talked about these problems before, and I would like to remind you that when I'm going through these homework problems, I'm not going to do all of them. It's just kind of a guide. Sometimes I do a mixture of easy, medium, and hard. Sometimes I'll only do easy and medium and leave the harder ones to y'all to kind of expand your minds and grow your minds. And if there's one that I think is impossibly hard, I'll do it myself. But again, remember, there is no grade. If you get a 72 on a homework, doesn't mean you get a 72. That means you've got a 100 because you participated. All right, so let's get it. Some friends drive from town A to B to C to D. So just generic town names, and then back to A. So they've made a round trip. Might call this the traveling salesman problem, the simple version of it. How far do they drive in all? So we're not asking for an area of this four-sided figure. We are asked for the perimeter of it because they went from A to B, so they went 85 miles. Then from B to C, which is 127 miles. From C to D, which is 146 miles. From D to A, or back home maybe, 73 miles. So we just need to add those up. Now, you are allowed calculators in this class, so I'm not going to, what's the word? I want to say a nice word. I'm not going to get super upset if I see you just adding these four numbers. If I see you go 85 in a calculator plus 127 plus 146 plus 73. And we get 431. So I'm not going to cry a river if I see someone using a calculator for that. However, you should also be capable of doing this on your own. You should be capable of adding 85, 127, 146, and 73. And if you don't want to add all four at once, you can do 2 and then the next and then the next. Say 5 plus 7 is 12. 12 plus 6 is 18. 18 plus 3 is 21. So then you carry your 2. The 2 plus the 8 is 10. Plus the 2 is 12, plus the 4 is 16, and then 16 plus 7 is 23, carry the 2, and then 2 plus 1 is going to give us 4. And maybe you don't put the 2 here, maybe you keep it up here because there was a space here. That's up to you. It doesn't really matter. Either is fine if you have it on the very top or just there. But we get the same answer, 431. Now, what I need you to understand is that 431 is not the answer. In quantitative reasoning, in the real world, 431 is not how far they drove. 431 what? 431 glasses of water? 431 pens? 431 lampshades? 431 inches? 431 meters? 431 miles. Now, when you're doing your homework, almost all the time, those units are already there for you. So that's okay, but in the real world or on a quiz or in an actual assignment in 154, maybe those units aren't always there. So maybe you have to remember to say them or write them or type them. That's a big issue. If I ask you right now, what's the temperature outside? If you say, oh, it's 45, nope. Even if you say it's 45 degrees, nope. It's 45 degrees, roughly, Fahrenheit. Because when you just say 45 or 45 degrees, you're not being specific enough. And in the real world, we need specificity. Because there is a difference in 45 degrees Fahrenheit, which is a cool day, cold to some people, cold in my opinion, or 45 degrees Celsius, which would be a rather hot day. And then there's 45 degrees Kelvin, which you would just be a frozen block of ice at that point if you know anything about Kelvin. So units are a major emphasis of this course, getting used to saying your units. How old are you? Oh, I'm 55. Well, I'm not actually 55. Not yet. No, you're not 55. What is that, 55 days? 55 bobs? 55 years? Oh, there we go. All right, next up. The graph to the right gives estimates of the number of species for various kinds of insects. And there are several parts to this question. And remember with these questions, if you do something wrong, you get 3 attempts on each question. And then if you go through all of your attempts, you can just hit the similar exercise button or try again, depending on what it is. Remember, a lot of questions have the help me solve this and view example, which are very, very helpful. So the graph to the right, let's take a look at this graph. Types of insects, we got 5, beetles, ants, bees, and wasps. That's an interesting cluster together, ants with bees and wasps. Butterflies and moths, that at least makes sense together. True flies and true bugs. Okay, how many more beetles are there than true flies? So they want to know how many more beetles are there than true flies. So we have 300 beetles and we have 130 true flies. And spoilers, I'm doing something wrong here. And I'm not going to write out this because going to the annotate back and forth takes a lot of time. I'll do it sometimes, but calculator. So we're just going to do 300 minus 130. And it says 170. And what I'm about to write is going to be wrong. And you go, Mr. Beckner, that doesn't make sense. You did 300 minus 130. That makes sense. More than needs to subtract the two. And you might be thinking, oh, well, did we do the subtraction backwards? Should it be 130 minus 300, which is negative 170? No, actually, it's not it. What we did is we didn't pay attention. We did not read the chart in full. We read the 1 or 2 things we thought we needed, and then we just blazed on forward. And this is how people make mistakes. And this is how people ask the same question over and over and over. Read the chart. Number of species in, thousands. That's our issue. So all of these numbers have 3 extra zeros attached to them. And nowhere in this answer block does it say the word 1,000. If it did, then 170 would be fine because it would imply 170,000. So that means we need to put the zeros there ourselves. Now in general, having the comma separate the 3 zeros like so, or not having it separate them should be okay. There might be 1 or 2 times where I'm wrong there and then my math lab wants one with the comma or without, and it might say that explicitly, so always pay attention to the instructions. But just remember, you got as many attempts as you need, so ultimately it doesn't matter. All right, and that fixed it. The total number of species for all insect types. So all insect types, that means all 5 categories, and a total means to add them up. So again, in the interest of time, let's just use our calculator. 300 plus 350 plus 290 plus 130 plus 200. Enter. Let's check our numbers. 350, 290, 130, 200, and we get 1270. So if you do 1270 here, I go, oh, well, that's got 1,000 in it, so that means the number's in thousands. Spoilers, it's wrong. Because same issue as before, we need the extra zeros. And this time, I will put the commas there to show you that it works either way. And we got it. That issue of the units or the numbers having extra zeros or less zeros, whatever, that will be a constant issue. All right, C, there are fewer beetle species than species of the other insect types. Now this question is a little confusing with the wording. What a lot of people think they might do is they see the word fewer and beetle species than of the other type. They think, all right, we'll add all of these up, which we just did, and we got the 1270 number, and subtract the beetles. And that's wrong. Because it doesn't say the difference of all of them and the beetles. It says the difference of the beetles and the species of the other types. So we're only supposed to add up these 4 figures, these 4 numbers, the other types. So that'll be the total of everything that's not a beetle. And then we will subtract the number of beetles. So let's take the 350 plus the 290 plus the 130 plus the 200. And this should give us the total number of everything else, the last 4 categories, everything but the beetles. So that is the sum of all the other insect types. And now we want to know how many fewer beetles are there. So we subtract the number of beetles. So we subtract 300. So minus 300. Don't forget, we'll be putting 3 more zeros on this. It looks like we get 670. So 670. I'll put a comma again, but I don't need it. And we got it right, 670,000. All right. So this problem right here I love because this was very relative to my life last semester, not with Countertop, but with flooring. Had to rebuild, I'm actually still in the process of rebuilding the bathroom. It takes forever. I mean, complete rebuild, everything, and we don't need to talk about all that, but another aspect is I might be redoing some counters soon because of that in another room. All right, so find the area of the countertop shown in the diagram to the right. First of all, for a rectangle, area is equal to the length times the width. And again, that's for a rectangle, which this is not a rectangle. That is several rectangles put together. Here is one rectangle. Here is another rectangle. And then here is a third rectangle. And that's not the only way I could break this up. I could actually break it up several other ways, but this is going to be the most convenient. Now I'm going to erase those because they're kind of covering the numbers, at least in one spot. So we're just going to take these 3 rectangles, this one being the first one, and we're going to find the area of each of them and then just add it together. It's something known as a superposition in fancy math. You'll never hear me say that term again, but it just means you can add up all the individual sections. So this area, let's call A1, would be the length times the width, so 77 inches times 15 inches, which, again, you could do that on your own, but calculators are perfectly fine. That's going to be 1155. Now, since these were in inches, as we will be discussing more in the semester, area is always in square inches or inches squared. Let me try and not cover anything this time. For area 2, I'll do that in the red one. So we'll call this area 2, which it says this width is 15, and then this distance right here is actually not known. We don't know the length from here to here. You might say it's 160, but it's not. 160 is from here to here, which there's gaps. So what we can do is we know that this spot right here is 15 inches, and we know this spot right here is also 15 inches. The whole thing across is 160 inches, which means that top section should just be 160 minus 15 minus 15. We're just going to subtract those two ends to essentially cut them off. So again, from here to here, this distance right here, that would be 160 minus 15 minus 15, which is 160 minus 30, which is 130. Or you can do 160 minus 15 is 145, minus 15 is 130. That's the more appropriate way to do it. So that width is 130 inches, and then this length is 15 inches. And you might say, well, Mr. Beckner, you called the 15 the width before. Which is which? Doesn't matter. Call them whichever you want. So we're taking the 15 times the 160. 15 times 160. And you get 2,400. And that would be in square inches. And then for area 3, which we'll do in blue, that is this one. Now these, the 15 and the 38, these are the true dimensions of that one. So that's just going to be 15 by 38. And we get 570. So 570 square inches. And then the total area Why does that look like an A? It's just the sum of the three independent areas. So the 1155 plus the 2400 plus the 570. 1155 plus 2400 plus 570. Check my numbers, 1155, 2400, 570, and we get 4125. And that would still be in square inches. So that should be our total area. Let's see if we got it right. 4125, and see their units here are square inches, which is appropriate. That's just a different way of writing it this way. Inches squared, square inches, they're the same thing. And it says we did something wrong. Oh, I know why. I said that, so this, I told you I make mistakes occasionally, but we hunt it down. And honestly, we learn more by making mistakes and correcting them. So here was my mistake. Remember I said that, yeah, that'll work. That width was 130. I was rushing. And when I did this area right here, I used 160 instead. So I was supposed to use 130, so we're going to correct that. Like I said, I do mistakes on purpose sometimes. Sometimes I don't do them on purpose, but we catch them and we correct them. So then that answer should not be 2400. 15 times 30 times 130 is 1950. Sorry for the color. So let's just change this 2400 to 1950. Let's see, 1155 plus 1950 plus 570, and we get 3625. What did I do wrong this time? One 155, 1950, 570. 15 times 38 is 570. 77 times 15 is 1155. The 15 times 130 is 1950. Something's not making sense. Well, that's awesome. Hold on a second. Did I write the wrong thing? I did. Okay, I was just looking at that. 3675. See, it's those little details that can get us all. I've even said to y'all, I am not just the president of this fan club. I'm also a member. And there we go. We got it right that time. I knew I did it right that time. I was checking my numbers. Thank you for pointing that out. I was about to catch that if you hadn't. Systems of checks. It's just, not getting a wrong answer. We don't want to freak out over that. We just have to go, okay, let's reassess what we did. Let's find our mistake. We found the mistake. And then, oh, okay, we just had a typo. We wrote a 2.5 instead of a 7.5. And it's probably because I was looking at this number when I was typing it. I have a feeling that's what my brain did. All right, cool. So let's clear our screen. Let's move on. All right, we're gonna skip that one. Like I said, we're not doing everything. We're just picking parts out to make sure we hit all the important topics. Here we go. This is one I wanted to hit. The area of Lake A is about 22 million square meters. and the area of Lake B is about 11 million square meters. Lake A is how many times as large as Lake B? So A is 22 million square miles. B is 11 million square miles. And the question they ask is Lake A is how many times as large as Lake B? In other words, if you took Lake B times some number, you would get Lake A. The question at hand is, what would the number be that you'd have to multiply B's value to get A's value? Now the number here is pretty easy to determine because these are nice round numbers, 22 and 11. I mean, well, one is double the other, so this answer is clearly either a 2 or a half. They're not always so clear, cut, and dry, though, so in the future, we might want to use algebra for this. It's kind of like having a an 11x equals 22, and then you just solve. But if we take B, which is 11, times some number to get Lake A, which is 22. So 11 times what number is 22? Well, the number has to be 2. It's the only way it would work. Now, the algebraic way of doing this thing would be saying 11 times x is equal to 22, and then whatever you do to one side, you do to the other side. We'll be talking about this in more detail a later day, but just showing you preemptively what it is. When you divide by 11, they cancel. 22 divided by 11 is 2, so you get x equals 2. So it's twice as large. Or 2 times larger. There we go. Screen. Two numbers, the same distance from 0 on the number line, but our opposite sides are called opposites. Like -5 and +5, or -12 and +12, or 17 and -17, or a half and -1/2. They're called opposites. They're equidistant from 0 on the number line. There we go. All right, mark the numbers -1, 4.5, and 3 on the number line. So -1, and we're going to drag these. There would be the -1. The 4.5, if we click and drag, that's halfway between 4 and 5. Then the 3, that's a +3, so that would go over here. Opposite of 14, remember opposites, you just change the sign, so that would be -14. Absolute values just gets rid of the sign of the thing inside of it. So the absolute value of -6.2 is just 6.2. Now before we move on, I want to point out that again, absolute values just delete the sign. Oops, wrong number. So if I had the absolute value of +6.2, oops, there we go, this would be 6.2. You don't change its sign. So the absolute value of -6.2 and +6.2 is the same. They are both 6.2. Opposites always change sign. The opposite of 6.2 is negative. The opposite of -6.2 is positive. All right. Here we go. Find the sum of the pairs, use the number line as a visual check. Honestly, I'm really not going to emphasize teaching addition and subtraction with number lines. I'm going to go straight to brass tacks. Now again, this is something that you are technically supposed to already know. The math 1, 2, 3 sequence or whatever, depending on when you had it at TCC or MDEs and whatnot, that is all prereq knowledge. I'm not technically supposed to have to teach you that stuff in here, but we do because I know some of you need the help. So, our addition and subtraction rules. All good? All right, so our addition and subtraction rules state that if two numbers have the same sign, add the numbers, keep the sign. And I'm going to capitalize some letters for reasons. And if two numbers have opposite signs, then subtract, different signs. I don't want to use the word opposite. That's for later. Different signs. They mean the same thing, but I'm choosing my words carefully because I'm going to do an abbreviation. So if two numbers have different signs, then subtract the numbers, larger minus smaller, ignoring signs, and keep the sign of the larger. Now, these rules are technically for addition only, but you can change subtractions to adding negatives. I'm going to highlight some letters. Because I like abbreviations. They always helped me remember things. Two numbers have the same sign, then you add the numbers and keep the sign. SAC, S-A-K, SAC. Pretty easy to remember. I'm not going to give you the please excuse my dear Aunt Sally version of it because it's just 3 letters. It's pretty easy to remember. SAC, hacky sack. If two numbers have different signs, another word again for that is opposite signs, but I like the word different for the D, then you will subtract the numbers. And when I say subtract, it could be the first minus the second, it could be the second minus the first, you're just ignoring the signs for that part. You just take whatever is larger and then subtract the smaller. So you might say to subtract them in absolutes. That would be the fancy way of saying it. And then you keep the sign of the larger number. So I've highlighted DSL, which is a type of internet, one of the first high-speed internets back in the early 2000s that was mainstream. So those are our rules. Sorry, I need about 45 seconds. I'll be right back. All right, thank you for your patience. So you got to know these rules inside and out. And you might go, well, Mr. Beckner, I got a calculator all semester. Why would I need these rules? Trust me, these basic rules can come up every now and then. Plus, if you're just doing something quick like 2 and -3, do you really need a calculator for that? You should be able to do that on the fly. All right. So again, these rules are for addition, but if you see something like subtraction, if you saw 5 minus 3, which you can change this to, instead of writing it as a subtraction, you can add a negative. So 5 plus -3. That would be the same thing. And then these are opposite signs. These are different signs, a +5 and a -3. So we're going to subtract them. 5 minus 3 is 2. And then you keep the sign of the larger. 5 is bigger than 3. So it's a +2. What if you had a double negative? What if you had 5 minus -3? How do you handle that? Well, you're just going to take the opposite of the -3 and change that to a plus. So 5 plus 3. Some people like to say 2 wrongs make a right for this. They cancel each other out. And that's true too. This is actually the multiplication rule of negatives that we'll get into sooner than later. And then 5 plus 3 is 8. All right, so let's try those out on a couple homework problems, which is, I'm so not used to having to go to that window. So 4 plus negative 6. So these are different signs. So we're going to subtract the bigger minus the smaller, the 6 minus the 4. Again, I ignore the negative for that subtraction part. 6 minus 4 is 2. It's just a question of, is it positive 2 or is it negative 2? And that's where he said, oh, we're supposed to keep the sign. Oh, these menus are killing me. There we go. I know you can't see the menu that was hiding something, but then we keep the sign of the larger number, which again, in this case, the 6 was larger. So negative 6. And there we go. Negative 2 is the answer. Negative 18 plus negative 97. So these would be the same sign. So you're going to add the numbers, and getting into 2 and the 3 digits, this is when I say, okay, pull out the calculator if you really want, but you should still be capable of handling these. So we go negative 18 plus negative 97. But I'm going to ignore the signs. I want to make sure we at least can get that. So just, these are the same signs, so I'm going to add them. 18 plus 97, which would be 115. But we're supposed to keep the sign, so they were both negative, so it should be a negative 115. Check it, and we got it right. Negative 14 plus 4. These would be different signs, so we're going to subtract them. We'll do the 14 minus the 4, which is 10. And then we keep the sign of the larger. 14 is larger than 10, so negative. Now notice I'm saying 14 is larger than 4. I think I said 10, but I meant to say 4. 14 is larger than 4. Negative 14 is actually smaller than positive 4, because you're talking about their order on a number line. Whichever is furthest to the right is the bigger number. But for these rules, I'm not talking about the negative 14. I'm just talking about the 14. All right. When you've got a series of multiple ones, just do them one at a time. So the 21 plus the negative 16, those are different signs. So we're going to subtract 21 minus 16 is 5. And the 21 is bigger than the 16, so it should be a positive 5, and I don't need to write the positive sign. You can, but it might confuse some people. But you still have the plus negative 19 here. 5 and negative 19, positive, negative, those are different signs. So DSL, subtract and keep the sign of the larger. 19 minus 5 is 14. But 19 is bigger than 5, so keep its sign, which is negative. So negative 14 should be our answer. There we go. All right, decimals. I mean, again, you got your calculator, so I don't want to focus too much on that. I want to get to the multiplication and division stuff now. So negative 2.2 times 3, and we'll start with the decimal one since we didn't do the addition subtraction stuff. So what's our rules for multiplication and division? And there's no little asterisks for this. They're the same whether it's multiplication or division. Two numbers have the same sign, and the answer is positive. Two numbers have opposite signs, the answer is negative. I use the word opposite instead of different this time because I like that for the abbreviation. So I'm going to highlight those special letters that I also capitalized, SP and ON. Now you could write these as two different things, but I actually like to just write it as one, spawn. Spoon with a missing O, or spawn as in the abbreviation of spontaneous. Like our heads spontaneously combust after learning too much math, hardy har har. So I like SAC, DSL, and SPAN. That I have found is very helpful for students that have a hard time remembering their sign rules. So SAK and DSL are strictly for addition and subtraction. Those rules do not apply for multiplying and dividing. SPON, same positive, opposite, negative. Those rules only apply for multiplying and dividing. What do you think students do more than anything else? They swap the rules. They'll be doing a multiplication and they use the addition rule, or they'll be doing an addition and they're using the multiplication rule. Just they flip-flop them, or they always use SAK and DSL, whatever. But again, this is basic bare bones stuff. You are supposed to know. All right, so let's try out some of these. if my window will let me. So negative 2.2 times 3. Again, we'll talk about decimal math a little bit later. For now, we can just say, all right, it's on the calculator, it's fine. So I'm going to ignore the sign aspect of it, though. I'm just going to focus on the 2.2 times the 3, which is 6.6. Basically, you just add up the total number of decimal points from the two numbers here, and that's how many you need in the answer. But that's a negative, that's a positive, so these are opposite signs. Opposite means the result's negative, so it should be negative 6.6. Now you might be thinking, Mr. Beckner, why didn't you just type the negative in your calculator? You could have done that too, right? Yes, I could have. But here's the thing. Different calculators have you typing the negative at different times. Sometimes you do it first, sometimes you do it after you type the number, and you have a different calculator than I have probably. So maybe I do it first, maybe you do it second, or vice versa. So at least I know the results, I know what to expect. That way, if maybe me goofing up with my calculator or using a different calculator and it produces a result I don't expect, I know to question it. There's math I can teach students that calculators can't handle because in the middle of it you've got some number with 100 zeros. So your calculator just breaks and it goes, nope, it's too big for me to handle. But I can teach a student how to handle it in like 15 seconds because they get to skip the giant numbers. Calculators are not everything. All right, 58.1 divided by negative 7. Let's go ahead and know whether the answer is positive or negative. This is a positive, this is a negative, so these are opposites, which means the result should be negative. So now I can just focus on the 58.1 divided by the 7. And I get 8.3. Now maybe you say, well, let me see what my calculator does if I do type the negative. So 58.1 divided by negative, and see when I type the negative there, it actually made the 58.1 negative. So this calculator, I was supposed to type it second, not first. Just because look, the 7 thinks it's positive. The negative isn't even up there. So my calculator has told me the answer is 8.3, but I know it's negative 8.3. See? I typed what I thought would be the right thing to do. I mean, admittedly, I knew it was wrong. That's why I'm doing this. That's why we're talking about this. I typed what I thought were all the right things in the calculator, and it gave me a wrong answer. Because what I was really supposed to do was 58.1 divided by, type the 7, then the negative. This calculate here, you do the negative after, but my TI-83 and my TI-30, I do them first. Now I have the right result. And you could even see before that the negative was nowhere in question up here. So the calculator didn't do anything wrong. You did. I'm pointing my finger at me right now because I'm the one that typed it, but you get what I'm trying to emphasize. All right, a division and a multiplication. Uh-oh, we're mixing steps up. What do? Order of operations. PEMDAS. PEMDAS, baby, please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally, just a helpful mnemonic device to remember your order of operations, the steps of how we process our arithmetic rules. P standing for parentheses, E standing for exponents, M standing for multiplication, D division, A addition, and S subtraction. And I could go on Facebook right now if I still use Facebook, and I could wage a war with this and give a problem, and I'd have half of people answering one thing, another half of people answering another thing, everyone saying they're right, and they're fighting and they're arguing. Even the people that are wrong just know they're right, and they go, no, PEMDAS is 6 steps. You multiply, then you divide. Guess what? They're wrong. PEMDAS is not 6 steps. It's 4 steps. It goes first, parentheses. That's going to be annoying. Second, exponents. Third, multiplication and division. 4 is addition and subtraction. So during steps 3 and 4, not 3/4, I'm just saying during steps 3 and 4 there, So during steps 3 and 4, you do them in the order you see from left to right. That is extremely important. You do not do all the multiplications and all the divisions. I'm going to say this many times. You do not do the multiplications then the divisions. You do not do the multiplications and the divisions. You do them in the order you see them from left to right. So if you see a division, then a multiplication. So if you see something like 10 divided by 2 times 7, someone on Facebook or another math class or a student in here who's not paying attention is going to say do to 2 times 7 first, which is 14, and then they're trying to do 10 divided by 14, which will give us a fraction or a decimal, and that's okay, but it's not the answer. You're supposed to do the division, then the multiplication, because that's the order you see them written from left to right. So 10 divided by 2 is 5, and then 5 times 7 is 35. Or if we saw something like this one I had typed up ahead of time, 4 times 8 divided by 2 divided by 4 times 3 times 2. So this is another symbol for multiplication. The slash is another symbol for division, FYI. I think I just deleted something. There we go. I was trying to respond to a PM. So this is why I like having pre-recorded stuff. It's very difficult to answer questions and lecture at the same time. All right, so 4 times 8 divided by 2 divided by 4 times 3 times 2. Someone's going to say 4 times 8 is 32, 4 times 3 is 12, and then 12 times 2 is 24, and then go in and do the divisions, and that would be wrong, 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 wrong. You do these from left to right. So you say 4 times 8 is 32. I'm just going to write everything after that. I'm not going to do more than one thing at a time. So then divided by 2, divided by 4, times 3, times 2. Then we do the 32 divided by 2 because it's the next thing from left to right in multiplication division, which would be 16. Then the divided by 4 times the 3 times the 2. 16 divided by 4 is 4. 4 times 3 is 12, and 12 times 2 is 24. I can guarantee you that if you did your multiplications, then your divisions, you would get a different answer. Now, maybe once in a blue moon, you get lucky and you get the right answer doing things out of order. That's just luck. If you do these things in the wrong order all semester, you will make countless mistakes. The same property works for addition and subtraction. If you see a subtraction before an addition, you have to do the subtraction, then the addition. So I don't say 3 plus 10 is 13 and then 5 minus 13 is negative 8. That is wrong. I do 5 minus 3, which is 2, and then 2 plus 10, which is 12. I don't know why I just wrote, I was looking at 10. Again, if I had done the addition first, 3 plus 10 is 13, and then I'd say 5 minus 13, that would be negative 8, because 13 is bigger than 5. 13 minus 5 is 8, so negative. This is the correct answer. These are correct answers. What if you see an addition and then a multiplication? 5 plus 3 times 4. Someone on Facebook or someone not paying attention, and again, every now and then I miss something too. Attention's not perfect for anyone. Someone's going to say 5 plus 3 is 8, and then 8 times 4 is 32, and that's wrong, wrong, wrong. Because what you're supposed to do is the 3 times 4 is 12, because multiplication comes before addition. Then the 5 plus 12 would be 17, and that is correct. Pay attention, take your time, don't rush. Pay attention, take your time, don't rush. We already saw what happens when people rush or when they have just too much information on the screen all at once. So let's try out a couple of these. And again, the homework problems that you'll see will be the exact same structure, but with different numbers. Like if you go to Number Sense, that homework, problem 26, you'll have something that looks like this, but maybe it's negative 15 divided by 3 times, I don't know, negative 5. So we have a division and a multiplication. Someone's going to say do the multiplication first, but they are wrong. You do the division first. Let me do this. That annotate feature is really annoying to me, and as you can see, my handwriting looks way worse when I use it. This will be for later, sooner than later. So the negative 12 divided by negative 3 times negative 3. We do this first. There are no parentheses. Yes, there are, Mr. Beckner. These are not parentheses. These are not parentheses. That is just used, yes, I know it is a parentheses, but what I mean is mathematically it's not a parentheses. When we say P for parentheses, that means there's stuff to do inside of there. There's nothing to do inside of this parentheses. There's nothing to do inside of this parentheses. So they don't count as parentheses. This is just because we got a series of negatives and operations that we don't want to mess our eyes up. So negative 12 divided by negative 3. The rules for multiplication and division were same sign, then the answer is positive. 12 divided by 3 is 4, so that would be a positive 4. Then times our negative 3. Again, the rules for multiplication and division, different signs, the result's negative. So 4 times 3 is 12, so that's going to be a negative 12. So let's see if we got that right. We do. Oh boy, here we go. Here we go. Negative 21 times 7. That parentheses is really unnecessary since it's positive, so I'm going to change notation. Then plus 5 times 7 over negative 7. And I'm going to go ahead and fix this minus a negative. Whenever you see those, change it to adding a plus. So negative 7 plus 3. Now, when you have fractions with stuff going on top and bottom, these divisions, what they actually imply is that there's a parentheses here and a parentheses here. Most people generally don't write them until we get to big, kooky, crazy formulas in Chapter 9, and that's okay. But what you should just think about is focus on the top by itself, focus on the bottom by itself, and then at the very end, divide or reduce. So the top and the bottom are like their own problems by themselves until the very end. So in the top, we got multiplications and additions. We should be doing the multiplications first. The 21 times the 7, and if a double-digit number is too big for you, remember, you can pull out the calculator to ease the pain. 21 times 7, although, again, you should be capable of it. That's 147, but we got a negative times a positive, so that should be a negative 147. The 5 times the 7 is 35. I can actually go ahead and do that step now because it's separated by a plus sign. If you wanted to wait, then wait. I'm not changing the bottom for now. Now the top, we got a negative 147 plus 35. Different signs, so we subtract and keep the sign of the larger. Once again, in the interest of time, I know a lot of you are probably just going to go, well, how did I do that? Oh, we got to do the 147, then the negative. And in this calculator, and a lot of calculators, this is a subtraction. This is not a negative, so be careful. And plus 35. That's why I suggest you need to know these rules. That way, if you biff in your calculator, you'll know you biffed. Negative 112. Well, I know the answer should be negative because the larger number is negative. And 147 minus 35 is 112. That's negative 112 over negative 7 plus 3. I'm skipping the calculator this time. Different signs, so subtract 7 minus 3 is 4, but keep the sign of the larger. 7 is bigger than 3, so it's negative. And then finally, negative 112 divided by negative 4. Fractions count as divisions. So 4 in 112 is going to be almost 30 times. It's going to be 28 if you show the long division. And I'll do that in just a minute. And then a negative divided by negative, this is the same sign, so the result is positive. So if you don't believe me, here's your 112 divided by your 4. I'm skipping the signs. There's your 28. How do we do that with long division? Very quickly. 4 can't go into 1, so don't write anything over it. But 4 can go in 11 twice. 2 times 4 is 8. Subtract. 11 minus 8 is 3. Bring the next number down. 4 will go into 32 8 times. 8 times 4 is 32. And it subtracts perfectly, so there's no remainder. And boom, we get our 28. Let's make sure it's right. Wouldn't that be funny? If I make 2 big mistakes in one day. I knew I didn't. All right, square roots, as a reminder, you're just trying to find a number that when you multiply by itself makes the inside. but you can only have one number. You can't have additions and subtractions. So we're going to have to simplify the inside of that first. So that'll be the square root of 6 plus 9 minus 4. Additions and subtractions, do them from left to right. 6 plus 9 is 15. 15 minus 4 is 11. So that's the square root of 11. And you might go, what's the square root of 11? If you try and put it in a calculator, I think I need to change my view to scientific. Oh, I was already on it, wasn't I? See, if I hit square root first, that just takes the square root of the answer. So it's kind of like the negative. This is very much not like my TI-83. I type the 11, then the square root, and we get 3.31662, blah, 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 blah. Generally, in this course, when you get an answer like that, they're either going to tell you to round or maybe do an exact answer. And they say to type an exact answer. So if you type 3.3, it's wrong. If you type 3.316, that's wrong. Or 3.317 if you rounded appropriately, still wrong. 3.3166247.9, if you typed every single number up there, it's going to be wrong. They give you a hint, using radicals as needed. So what they actually want you to type is the square root of 11. Not something that's very common in this course. Usually we would approximate it. We also really don't do a lot of square roots in later chapters of this course, but still a good concept. All right. I think I got about 5 minutes left. We'll do this one, and then I want to get to that last topic. A student has a credit card balance of negative 3838. That's our balance. He then sends a check to the credit card company for $14.74. And then uses his credit card to purchase a camera for $613. And some film. I don't know why I wrote buy there. Let's do camera. And then some film for 11 bucks. What's the balance? So when they say that the balance is negative $3838, that means that they owe. And when you get your bill from a credit card company, they're not going to write it as negative. They're just going to write 3838. But you need to understand that in terms of your finances, that is a negative number because it is a debt. Debts and things you buy with a card are negative because you owe. Money that you pay for, like your check of $14.74, that would be a positive. So not all of these numbers have the correct signs. I just was writing them down. So the camera counts as a negative because it's a debt. The film counts as a negative because it's a debt, but the check is positive because that's what you added. Now, here's the thing. In the real world, you're going to flip all of these signs because you're going to see that balance of 3838 is positive. Then you're going to subtract the 1474, and then you're going to add the camera and the film payments. I get that. But in reality, this is the true nature of the debts and the payments being positive and negative. So we're just going to add all this stuff up. Probably going to be better to use a calculator with these bigger numbers. So let's do that. So negative 3838. Now I have to type the negative second. Then plus the 1474. Then we're going to minus the 613. And we're going to minus the 11. And we get negative 2988. So we still owe $2,988. Again, in the real world, I know that all of these signs would be flip-flopped in your head, and that's perfectly fine. You would call the balance positive 3838. You would subtract your payment of $1474, and then you would add the camera and the film, and you would say your balance is $2,988. But again, in terms of your debts and balances and incomes and all that stuff, that is a negative amount of money because you owe it. And you're going to get charged a lot of interest on it over time. All right, this will be the last thing we do, our digits. You do need to know your placeholder names and all that jazz. So we got 951872. And I'm going to try and write this as best as I can, but I'm using a drawing tablet and I'm writing at a 90-degree angle from right to left. This would be our, oh, good Lord, this is difficult. Ones. then our tens, then our hundreds, then our thousands, then our our 10,000s. This is distracting. Then our 100,000s. And then after that would be millions and 10 millions and 100 millions, etc. And this number doesn't have any decimals, so I'm going to just put some in here. So this is not actually part of the problem, but let's just pretend like I had a 5, 8, 3 here. There are no, everything after a decimal has a THS after it, so th, but there are no oneths. It starts with tenths, then hundredths, then thousandths, then it would be 10,000ths, then 100,000ths, then millionths, 10 millionths, 100 millionths, it's billionths, etc. So THS is for decimal values, just an S at the end for regular values. And again, there are no oneths, and that's because 10 tenths make up one whole. That's why we call these tenths, because it takes 10 tenths to make up one whole. So they just asked us what digit is in the hundreds place, and that would be the 8 based on, I'm sorry, I said what digit, what number is in the hundreds digit, the hundreds place. That would be the 8 here, not the blue one. Again, the blue stuff was not actually part of the problem. I was just covering something they didn't. One more, identify the place occupied by the 5-digit. So from right to left, ones, tens, hundreds, thousands. So that would be the thousands, not thousandths. Not that they gave you any of those, but the thousands. Insert commas as needed, then write the number as words. I'll do the comma part, but we're going to call it a day there. I'm not too focused on the word aspect. So from right to left, every 3 values gets a comma. So a comma goes between the 4 and the zeros. Then a comma is going to go between the 2 and the 1. And that should be it. 5, 6, 2, comma, 1, 7, 4, comma, 0, 0, 0. All right, and we're going to call it a day there. All right, so that was a pretty good session through that homework, number sense, decimals, everything from, oops, pulled up the wrong thing. The first week 2 assignment. So next time, what we'll likely do is talk about some of these note-taking skills in college transition. Maybe we'll do a little more math. We'll see. Like I said, I like to mix things up in here. Sometimes I won't do any of this stuff. I'll just be talking about Excel. Sometimes I'll give my own notes that are outside of this. Like I said, we'll mix it up. I will not always do questions from these homeworks ahead of time. Remember, that's really supposed to be just on you. But I like to use them as examples because I like to be able to push you in the right direction.